Here we are discussing an interesting question from the chapter functions. Here question is, let A be a set having element x such that x belongs to set of real number and x lies between minus pi by 2 to pi by 2 in closed interval, because equality sign are here. Okay, so greater than or equal to minus pi by 2, less than or equal to pi by 2. This is closed interval for this x. And B is also a set defined as an element y such that y belongs to set of real number and y lies between minus 1 and 1. This is also closed interval from minus 1 to 1. We have to show that the function f defined from set A to set B, from this set to this set, defined as fx is equal to sin x, is invertible, and hence find f inverse. We know that for showing any function to be invertible, we need to show that this function is 1 1 and 1 2 function. Correct? So let us see the solution here. Here function f is defined from set A to set B and defined as fx is equal to sine of x. And you know that how we can show that this function is 1 1 function? Fx1 is equal to fx2 implies x1 is equal to x2. So let x1 and x2 belong to domain, this closed interval, minus pi by 2 to pi by 2, such that f of x1 is equal to f of x2. Okay, so by the help of this definition of this function, fx1 is sine of x1, which is equal to fx2 means sine of x2. And this implies that x1 is equal to x2, as x1, x2 belongs to this interval, minus pi by 2 to pi by 2. You know, in this interval, sine function has unique values, different values for different points. Okay, for different values, we'll get different values of sine. So sin x1 is equal to sin x2 implies x1 is equal to x2 in this closed interval. So now we can conclude that this function f is 1 1 because if x1 is equal to fx2 is implying x1 is equal to x2. So we can write here, therefore f is 1 1 function. Now we have to show that function is onto function. Also fx is equal to sin x. Okay, we write here fx is equal to y. So therefore y is equal to sin x, and this implies sine inverse of y is equal to x. Means if y is any element in range of this function, or you can say codomain of the function, then with respect to this element y in codomain of the function or range of the function, we are getting a pre-image in domain. X belongs to domain of the function f. So corresponding to every element y in range or codomain, we are getting unique value x in the domain of this function. So this function is onto function. Therefore f is onto function. And as this function is 1 1 function and onto function, that is here f is invertible. Now we have to find f inverse, that we have already got here. sine inverse y is equal to x. Okay. So here given fx is equal to sine of x. Okay. And we write here fx is equal to y. Fine. Or x is equal to f inverse of y. Here we are getting sine inverse y is equal to x, and x is f inverse of y. So we can write here that therefore f inverse of y is equal to x is f inverse of y, and f inverse of y, I mean x is equal to sine inverse of y. Sine inverse of y. This is the inverse function of given function. So this is the answer. F inverse of y is equal to sine inverse of y. And if you want to generalize this, you can write f inverse of x is equal to sine inverse of x in the given domain and given range. Here, sine inverse of y, this is range of the function f inverse, and y lies in the domain of f inverse. Correct? Understood it? Okay. So this is the answer. Either you can write this or this. Both are the answer. This is in the same pattern. F inverse of y is sine inverse y, or you can write f inverse x is equal to sine inverse x. This is the inverse of this given function in the given interval. Okay, very interesting solution. Understood it? Okay, so remain in touch these videos. We have to see some more questions, and share these videos with your friends also, and hope you have subscribed this channel. And if you have any doubt, you want to need any clarification or want to give any suggestion, please write in the comment box. I will address it. Wish you all the best.